Hello everyone, myself Anil BV, second year student from Shri Venkateshwara College of Engineering. Today I am going to talk about Fourier series rectangular pulse, which is the topic of mathematics. Fourier series rectangular pulse. Introduction. Fourier series is a mathematical tool used to represent periodic function as sum of sine and cosine functions. The rectangular pulse is a common example of periodic function which represent a pulse of constant amplitude and duration. In this representation, we will explore the Fourier series representation of rectangular pulse. Let us see the definition of Fourier series. Fourier series is an expansion of periodic function f of x in terms of an infinite sum of sine and cosine function. As you can see in the picture, Fourier series formula. Fourier coefficient for rectangular pulse. The rectangular pulse is defined as f of x is equal to a for mod x t by 2 and f of x is equal to 0. Otherwise, the Fourier coefficients for a rectangular pulse are given by a 0 is equal to a. Fundamental frequency and period. The fundamental frequency is omega naught of rectangular frequency and pulse is given by omega naught is equal to 2 pi by t, where t is the period of pulse. The period of the pulse is the duration of one complete cycle of the pulse. The frequency of omega n is of the nth harmonic is given by omega n is equal to n omega naught, where f, as you can see in the picture, formula of fundamental frequency and period, where f is the frequency in hertz, t is the time to complete the one cycle in seconds, v is the wave speed, and lambda is the wavelength, omega is the angular frequency. Fourier series representation. The Fourier series representation of a rectangular pulse can be written as f of x is equal to a by 2 plus sigma of 2a by n pi, where n ranges from 1 to infinity. The first term a by 2 represents the DC component or the average value of the pulse. As you can see in the picture, this is the representation of Fourier series. Graphical representation of Fourier series. The Fourier series representation of a rectangular pulse consists of series of sine and sine waves. The amplitude of each sine wave decreases as the frequency increases. By adding more terms to the series, we can better approximate the shape of the rectangular pulse. As you can see in the picture, this is the graphical representation of the Fourier series. Fourier series coefficients visualization. The Fourier coefficients determine the amplitude and phase of each harmonic in the Fourier series representation. The DC component has the largest amplitude, followed by the first harmonic, and so on. The coefficient determine how much each harmonic contributes to the overall shape of the pulse. As you can see the problem regarding the Fourier series coefficient visualization. Fourier series convergence. The Fourier series representation of a rectangular pulse is an approximation and the accuracy increases as we add more terms. As the number of terms increases, the Fourier series converges to the original rectangular pulse. This convergence is known as Dirichlet theorem. Frequency spectrum. The frequency spectrum of a rectangular pulse shown as the amplitude of different harmonics. The DC component has the highest amplitude and the amplitude decreases for the higher harmonics. The frequency spectrum provides insight into the frequency content of the rectangular pulse. Aliasing occurrence in Fourier series. aliasing occurrence when the frequency of the harmonic in the Fourier series is greater than the frequency. The frequency is half the sampling frequency and it represents the maximum frequency that can be accurately represented. Aliasing leads to distortion and loss of information in the Fourier series representation. Even symmetry of rectangular pulse. The rectangular pulse function is an example of an event of symmetric function. An even symmetric function is a symmetric with respect to the y-axis, meaning f of x is equal to f of minus x for all x terms in the domain. The Fourier series coefficient for an even symmetric function have a special property. Odd symmetry of rectangular pulse. The rectangular pulse function is also an example of an odd symmetric function. An odd symmetric function is an antisymmetric which represent to the y-axis, meaning f of x is equal to minus f of minus x for all x is in the domain. The Fourier series coefficient for an odd symmetric function also have a special property. Half-wave rectification. Half-wave rectification is the process of converting a periodic function into a function that contains only positive half cycle. Half-wave rectification can be achieved by removing the negative half cycle of the rectangular pulse. The Fourier series representation of the half-wave rectified pulse will only contain the odd harmonics. As you can see in the picture, half-wave rectification. Applications of Fourier series rectangular pulse. Fourier series rectangular pulse is widely used in signals processing and communication system. It is used to analyze and synthesize the periodic signals such as square waves and pulse trains. The Fourier series representation helps in understanding the frequency, content, and harmonic distortion of these signals. Fourier series rectangular pulse in image process. Fourier series rectangular pulse has the application in image processing. It can be used to analyze and manipulate the frequencies present in an image. The Fourier series representation helps in compressing and enhancing the images. Limitations of Fourier series rectangular pulse. The Fourier series representation assumes that the rectangular pulse is infinitely long and has abrupt transition. Real Real world signals often have infinite duration and smooth transition, which may require more mathematical tools. Fourier series rectangular pulse provide a good approximation but may not accurately represent all types of signals, as you can see in the picture. Let us come to the conclusion. Fourier series rectangular pulse is a powerful mathematical tool used to represent the periodic function. It provides a compact and efficient way to analyze and synthesize the signals. Understanding the Fourier series representation of a rectangular pulse helps in understanding its frequency, content, and harmonic components. Thank you for watching this video. Thank you.